BZ Gamer 41, there is no height given, so I believe we have to use the law of sines or law of cosines here. So we need to find the area of the quadrilateral. All right. So if you were going to use the law of sines, law of cosines, like you'd have the angle side angle, but then I don't, I could find this opposing side length, but that's not really going to help me in my understanding to be able to find the quadrilateral. What I'm thinking we might want to do here is if I know this is 120 degrees, then I can figure out that to be 60 degrees. Now that's important because that's a special right triangle. And if I know a special right triangle, I can now I can make a 90 degree here. I can now find the height. So what I could do is if I can find this height here and also find this missing side length, then I have the height times the width and I have two triangles. Well, finding the area of a triangle is easy, right? Area equals 1/2 base times height. So if I have two right triangles, that'd be a lot easier to find the area of the rectangle and then subtract the two right triangles because I don't know what this figure looks like. This looks weird. So if we have 60 degrees, that's 24. Well, remember your special right triangles. If your hypotenuse is 24, your short leg is half of that, and your long leg is going to be 12 square root of 3. So then I have 12 plus 20 plus 12. That's going to be a 32. And then over here, if this is 6 and this whole thing is 12 square root of 3, then this is going to be a 12 square root of 3 minus 6. All right, so let's find the area of the rectangle. So the area of the rectangle is just going to be length, or let's just do base times height. Base times height, which in this case is going to be a 32 times a 12 square root of 3. And I don't want to rewrite that out, so I'll do 32 times 12, and I'll leave the square root of 3 out on side. So that is going to give me a 384 times the square root of 3. All right, now let's go and find the area of the two triangles and then subtract them. So let's call this area of triangle 1, and let's call this area of triangle 2. So area of triangle 1, that's going to be 1/2 base times height. So again, in this case, if you were to take this triangle, you could make, it'd probably be easy, it doesn't really matter which one's base of height, but I'll make this going to be the base, and then that'd be the height. So if you were to rotate it on there, you could look at it like that. Or actually, it doesn't matter. Let's do 32 as the base, and that would be the height vertical distance. It doesn't matter, actually. So we have a 1/2, and let's just do 32 times a 12 square root of 3 minus a 6. That's going to be a 16 times a 12 square root of 3 minus 6. And then I'm going to distribute that to both of them. 16 times 12, I should, but I'm not going to. 16 times 12 is going to be 192. So 192 times the square root of 3, and then 16 minus 6. Now, I'm sorry, 16 times 6, which would be 60, 90, 96, but I'm just going to multiply it anyways. Yeah, 96. Now, you might be asking me, why, Mr. McLogan, are you not using like decimals? Well, one, these are irrational numbers, so I don't want to multiply these until I finally get everything together. And then I'm probably going to be, since they all have a square root of 3, I can probably combine them close at the end. And I can get an answer that's going to be exact, and then we could do a rounded answer. So I'm going to leave everything with the radicals as they are. And then now let's go and do area of triangle 2. We'll have the base here of this one to be 12, and then the height here is going to be a 12 square root of 3. So I have a 12 square root of 3. All right, so I know 12 times 12 is 144. So therefore, to divide that by 2 would be a 77. No, that'd be a 70. 77, that'd be 154. So we do 6, that'd be a 72. So that's going to be a 72 times the square root of 3. Okay. Now to find our area of our shape, that's going to be this thing. All we're simply going to do is take the area of the rectangle, which is going to be 384 times the square root of 3, and we are going to subtract that from the area of these two combined. So that's going to be a 192 square root of 3 minus a 96, and then you could add it to a 72 square root of 3. The reason why I'm writing that up is because we can go ahead and combine these first before subtracting them. So let's do 192, plus 72? 264. 34 square root of 3 minus, what's it, 264 square root of 3. And then also, that's going to be plus a 96. So plus a 96, because remember, you have to distribute that negative to end those. So I'm combining these before multiplying them together. Actually, you know what? That's confusing. Let's just rewrite it properly, so therefore you can see what I'm doing. So 384 square root of 3 minus, this becomes a 264 square root of 3 plus a 96. Wait, no, let's do minus. So I'll do a minus 96. And now you can see, and now I'll go ahead and distribute that. We'll do that correctly. Boom, boom, boom. And now we can do 384 minus a 264. That's going to be 120. 120 square root of 3, and that's going to be plus a 96. So that would be your final answer in that card. I mean, you could factor, I'm assuming, out like a common factor between those two, but I would just leave it in that case. And then if you want to approximate it, you could do 120 times the square root of 3, and then go ahead and add that to 96, and that's going to give us a area, and I will just truncate it here at 303.84 if you needed to approximate it. So